Good morning, Cardinals. It's me, Mr. Ernst. And today we're going to be talking about something called the quadratic formula and why it's something that's going to be very, very useful for us. So, when we're looking at solving, we're already worked on solving quadratic formulas before or quadratic equations before. We know this one is a quadratic equation because it's got this handy little, it's got a variable raised to the power of 2. Our first strategy that we learned was something that was called factoring. And factoring was essentially where we broke these things into two sets of parentheses. We said x plus and x plus blank, and we needed two variables that were going to, or two numbers that were going to add to give me 5 and multiply to give me 1, which this basically came into guess and check. Problem with this factoring, though, is that there's no integers that are going to multiply to give me 1 and add to give me 5. So in this case, factoring has failed us and we can't use it. So factoring has failed. It was so excited to. Goodbye, factoring forever. Bam. Okay, so the next strategy we learned was called completing the square. Completing the square essentially said, okay, I got this equation, I know it's broken, but I'm going to try adding a number over here to try and fix it. So I'm going to add some number, I'll just say it's n. I'm going to add a number over here, I'll add that number over here, and that's going to allow me to fix the square, okay? Or in other words, complete the square. We say this one's broken, I can fix this one by adding a number to both sides, and then I can try and complete it from there. And when I'm looking at that, this is an equation that actually would work pretty well for completing the square. However, completing the square really starts to break down when you have a coefficient out in front of this x. For example, let's say a3. That's when completing the square starts to break down and you need to use the quadratic formula to help you out. You can still use completing the square to kind of solve this, but then you have to start off by dividing everything by 3, and then you're either working with numbers or you're working with infinite decimals, and it's just going to get really messy from there. So we're going to use something called the quadratic formula to help us out. Now, we've already worked with formulas before. For example, you may recall a squared plus b squared is equal to c squared was the Pythagorean theorem. This was a formula where we plugged in a value for a, b, and then we would solve for whatever the missing one was. This is very much the same thing, except we have all three of them this time. We have an a value. The very first one is our a value, our b value, and finally our c value. This is ax squared plus bx plus c. So you can see all these have a letter they correspond with. And the formula we're going to use looks like, drum roll, ba-bam, this. Now, I know this guy looks really intimidating when you first start off. There's a lot of stuff going on here, but this is nothing that you guys haven't seen before. You guys have seen squares. You guys have seen square roots. You guys have seen simple multiplication, division, and all this is saying that we have one equation that's being added together and one equation that's being subtracted. And we'll talk more about that later. So, to solve this, all we need to do is plug in the proper numbers to their proper spots. So let's start off with a. All the a's are going to be replaced with the number 3. So I'm going to replace this a. I'm going to replace this a with the number 3, and this a with the number 3. My next one is going to be replacing all of my b's with 5. Replace this, and this is now -5, and this one is now 5 squared. The last one, c is going to be 1. I only got one c. Now that I have all of my numbers plugged into this equation, all I really have to do from here is start going through and starting to simplify it. Simplify each of my terms. So first up, I have -5. Nothing's really happening with this guy, so I don't need to worry about it. Next up is 5 squared. I can simplify that. 5, keep jumping between layers. 5 squared is 25. My next term is 4 times 3 times 1. 4 times 3 gives me 12. 12 times 1 gives me 12 again. Still got 12. So this simplifies out to be 12. Down below I have 2 times 3, which can simplify to give me 6. Cool? Notice that the equation, as we start to simplify it, starts to get gradually smaller. Next up, underneath my square root, I have 25 minus 12. So I can simplify this grouping here. 25 minus 12 gives me 13. And this is about as simple as I can actually make this. Looking at this, the square root of 13, 13 is not a nice square number, so this is not going to come out to an integer. This is going to come out to some crazy decimal. If I had to guess, it'd be just above 9, so I would say, wait, no, just above 3. My guess is it would be like 3.4-ish, somewhere along those lines. Come out to an infinite decimal, an irrational number. So this is about as simple as I can really make this right now. I'm just going to move the 6 over. Our last part that we need to consider is the plus and minus here. Cool? This is essentially saying that I have two equations that are layered on top of one another. I'm going to kind of copy and paste this out. I'm going to remember to actually copy and paste it this time. There we go. Yoop. There we go. Bam. So I essentially have two equations. My first equation is negative 5 plus, square root of 13 all over 6. And my second equation is negative 5 minus the square root of 13 all over 6. So see how that kind of breaks off into two different ones? That plus or minus that we had here beforehand tells me there's two equations that are actually happening here. One of them where it's adding, one of them where it's subtraction. And those are my answers. So my final answer is x is equal to these two different answers. Oops, let me get rid of this. Negative 5 plus the square root of 13 over 6, and negative 5 minus the square root of 13 over 6. Those are my two answers. Remember, when you solve a quadratic equation, you are usually going to get two answers because a quadratic makes a parabola, and you are essentially looking for this answer and this answer. So my guess is, let me see, that's a negative plus a smaller number, minus a number. My guess is this one, this equation is probably this point there, and this equation down here is probably that point there. Cool? Quadratics always have, or usually have that same thing. So that's how the plus and minus works. But yeah, that's your final answer. X is equal to that and that. Now, if you really wanted to, you could, of course, get a calculator, find out exactly what the square root of 13 is going to be, find out exactly what this is going to be, which would be like 3 point something, negative 5 plus that. You could do this all the way down to where you get a nice, even decimal answer. But the problem with that is because you're taking the square root, the answer is going to be irrational, and therefore you are going to have to estimate. So you're not going to be able to say exactly what x is equal to. You're going to say x is approximately something like x is kind of equal to some answer. So in your assignment today, you have, I think, 6 problems that you're going through and doing and using the quadratic formula. I want you guys to leave your answers like this, where they look like this. The reason for that is because I want to see that you guys do know how to at least put the equation or the formula together, and to use the formula and to simplify it down as much as you possibly can. So most of your answers should look like this. Remember, you're going to have 2 of them for each, okay? Yeah, so as always, if you guys have any questions, please make sure you contact me in some way, shape, or form. And yeah, good luck on your assignment today. Bye.